So hello everyone, my name is Atharva Valve and today I am going to present my major project titled Sales Prediction using Multiple Linear Regression. In today's competitive business environment, companies invest a significant amount of money in advertising to different platforms such as television, radio and newspaper to increase the sales of their products. However, one of the biggest challenges for companies is determining whether their advertising expenditure is actually helping to improve sales. To solve this problem, I have developed a machine learning model that predicts product sales based on the advertising dataset, which contains the advertisement expenditure on TV, radio, newspaper, along with corresponding sales values. You can see which is To build this prediction model, I have used a multiple linear regression algorithm, which is suitable for predicting one numerical output using multiple input variables. In this project, I first imported the required libraries, located the dataset, analyzed the relationship between different advertisement platforms and sales, trained the multiple linear regression model, evaluated its performance using different metrics, and finally improved the model by applying feature engineering. So in this, the first task is to import all the required libraries. The library is a collection of pre-written codes that provides useful functions. Instead of writing every function ourselves, we simply import the required library and use their built-in function. Since the project involves data handling, mathematical calculation, statistical analysis, data visualization, and machine learning, different libraries are required. So very first is pandas. Pandas is one of the most important libraries in data science because it helps us work with data in a tabular format, similar to an Excel spreadsheet. Our data set is stored in a CSV file, and Panda allows us to read, organize, filter, and analyze the data efficiently. The second library is NumPy. NumPy is mainly used for mathematical and numerical operations. Machine learning models perform many calculations, and NumPy makes this calculation much faster and more efficient. The third one is Seaborn. Seaborn is a data visualization library that helps us create attractive and informative graphs. Throughout this project, Seaborn is mainly used to create pair plots and heat maps, which help us understand the relation between different variables. There is Skype. SciPy provides several statistical functions. In this project, I specifically imported the skew function, which is mainly used to measure the skewness of data. And this is a matplotlib inline. This is a Python function in which indicates that all the output is going to behind beside the code only. It will not create a separate window for the matplotlib output. It will give the output just below the code. And then last we have imported the matplotlib. So matplotlib provides the basic plotting functions while Seaborn builds on top of matplotlib to create more attractive graphs. Both libraries are commonly used together. So after importing all the required libraries, the second task is to load the data. The dataset is simply a collection of related data organized into rows and columns. In this project, I have used the advertising dataset, which contains advertisement expenditure on TV, radio, and newspaper, along with the corresponding sales values. So here, so understanding the dataset contains four columns. As you can see, TV, radio, news, and sales. TV column represents the money spent on television advertisement. The radio column represents the money spent on radio advertisement, and the newspaper represent the money spent on newspaper advertising. Finally, the sales column represents the sales generated after spending money on these advertisements. So now, uh, with this line that is here. So here I use the read CSV function provided by Pandas to read the CSV file. The data is stored in a data frame called DF. A data frame is a table-like structure consists of rows and columns. You can see it. So in the next line, the head function displays the first 5 rows. However, the head 10 displays the first 10 records of dataset. This allows us to verify that the data has been loaded correctly. The df.info shows all the things like if there is any null value and all everything is in the df.info. After loading the data, our third task is to finding a relationship between the feature and the response. Before building any machine learning model, it is important to understand the relationship between the input feature and the target variable. To visualize these relationships, I use a pair plot. A pair plot is a visualization technique that compares different variables using scatter plot. Each point on the graph represents one observation from the dataset. By observing the pattern of these points, we can identify whether two variables are strongly or weakly related. Here, I compared three advertisement features: TV, radio, and newspaper with the sales variable. As you can see, we have taken the X variable as TV, radio, newspaper, and the Y as sales. And then yeah, it has given us the plot with the given aspect ratio and the height. So in the first graph, which is TV versus sale, it shows the relationship between the TV advertisement expenditure and the sales. We can observe that the TV advertisement spending increase, sales also increase. The point follows an upward trend, indicating a strong positive relationship. This suggests that the TV advertisement have a significant impact on sales. Second graph is radio versus sales. Second graph compares the radio advertisement with sales. Here also we can observe an upward trend. As the radio advertisement spending increase, sales generally increase. Also the points are slightly more scattered than the TV graph, but the relationship is still clearly positive. The third graph is newspaper versus sales, which compares the newspaper advertisement with sales. Unlike the previous graphs, the points are randomly scattered. There is no clear upward trend. This indicates that the newspaper advertisement have a weak relationship between sales. So after finding the relationship, the fourth task is to create a model of the multiple linear regression model. So in this task, I build the multiple linear regression model. Multiple linear regression is a supervised machine learning algorithm used to predict one numerical output using multiple input variables. In this project, the input variables are TV, radio, and newspaper advertisement expenditure, and the output variable is sales. So here, as you can see, the x variable in the x variable there are the TV, radio, and newspaper. We have dropped the sales, and in y we have sales. So all the three, that are TV, radio, and newspaper, are independent variable, and the sales is a dependent, as the sales is dependent on the those three. Of creating a model. Here I create an object of the linear regression class. At the stage the model is created, but has not yet learned anything from the data. In this, the fit function trains the model using the input feature and the corresponding sales value. During training, the algorithm learns how each advertisement platform contributes to sales. The training is the process where the machine learning algorithm studies the dataset and identifies patterns between the input variable and the output variable. After training, the model becomes capable of making predictions for new data. Here we have printed an intercept. Yeah, intercept. What is intercept? Intercept is a constant value in the regression equation. It represents the predicted sales when all the advertisement expenditures are zero. Here is the intercept. It has given us the intercept over here, and this is the coefficient. The coefficient represents the importance of each feature. A large positive coefficient means that the increasing the feature increase sales. A negative coefficient indicates that the feature contributes very little or may slightly reduce the prediction. Here we can see the TV radio has the positive value of the coefficient while the newspaper has the negative. Now here we have feature coefficient. Here I've created a dictionary that maps every feature name with its corresponding coefficient. This made it much easier to understand which advertisement platform has the greatest influence on sales. So here we have all the feature names, that is TV, radio, newspaper, and the coefficient which are this. Then we have created a feature coefficient dictionary which has the feature name, that is TV, radio, newspaper, and has its corresponding coefficient which we can see it has displayed the output over here. Then to verify this observation, I have created the correlation heat map. A correlation heat map measures how strongly two variables are related. Its value range from -1 to 1. The value close to +1 indicates a strong positive relationship. A value close to 0 indicates a little or no relationship, while a value close to -1 indicates a strong negative relationship. So here, in this heat map, you can see the syntax of a heat map, which is this. So the heat map shows the correlation between every pair of variables. The value 1 on the diagonal means that every variable is perfectly correlated with itself. The correlation between PV and sales is approximately 0.78, which indicates a strong positive relationship. Correlation between radio and sale is approximately 0.5, indicates a moderate positive relationship, while the correlation between newspaper and sale is approximately 0.23, which is a very weak relationship. This result supports our earlier pair plot analysis. Since newspaper has the weakest relationship with sales, the next step is to determine whether removing it affects the model performance. So here we are going to do a feature selection. The feature selection is the process of selecting on the most useful input variables for the machine learning model. Removing unnecessary features often makes the model simpler, faster, and sometimes even more accurate. So, why feature selection? Not every feature selection contributes equally to the prediction. Some features provide valuable information, while others contribute very little. By removing the less important feature, we reduce unnecessary complexity. Here we are going to make a first model which includes only TV and radio. After training the model, we will calculate the R square score. So here we have make a model LM2, initializing the model with a linear regression, then training the model on the full data set, which is X TV radio, which has only the TV and radio value, and Y scale, as you can see, Y scale initialized here, and then uh, this will predict the value, and you save that in the LM2 predict. And then in this to calculate the R2 square, there is a function R2 square in which it will compare Y and LM to predict, which the model will predict, and will give us an output of R square. So R square score measures how well the model explains the variation in the output variable. It ranges between 0 to 1. A value closer to 1 indicates a better prediction performance. The first model gives us a score of approximately 0.897. So similarly, we have built a second model which includes newspaper value. Previously, there is only TV and radio, but in this model, we have TV, radio, and newspaper. Others are same steps in which we have initialized with linear regression. We have fitted all the features that are TV, radio, the newspaper, compare it with Y. Then it will predict the value. It will store that in LM3 predict, and then it will calculate an R2 score by comparing the cells and the predicted value, and then it will give us an R2 score, R square score. So here in the model 2, this model have produced an R square score of approximately 0.897. So the difference between the two R square score is extremely small, since adding the newspaper feature does not significantly improve prediction accuracy. It is unnecessary to include it. Therefore, I select TV and radio as the final feature. So after this, there is a task 6. It is model evaluation using train and test data set. So until now, the model has been evaluated using the same data on which it was trained. However, in real-world application, the model should perform well on completely new data. Therefore, I use the train test with technique. So it is a inbuilt technique in which we have to split the data into train and test it, as we have imported it from the SQL model, and we have to do the thing. So here we can see the x. We have dropped the x and y. So we are taking. So here we are taking all the three columns that are TV, radio, and newspaper. So we are dropping sales over here, and in y we are taking sales. So now we are splitting the data. We are splitting the x into two parts. That is the train and test, and y also into two parts. That is train and test, and we are using that train test bit over here, xy, and random state equals to 1. So random state equals to 1 gives an input the to the inbuilt function that you can take any random state. We can take any random state, that is 1, 2, 3, 4, 5, 6, 7, 8, 2 until any, but we have to take it same throughout the code. As you can see, we cannot take here 2 or 3, otherwise there will be no similarity between the output of the two. So that's why we have to take the random state same overall in the code, but we can take any random state, but from the starting to the end we have to maintain that. And then in here we are creating a model LM4 with the training state now, which will predict the X state and the prediction, which will be compared with the X state, and if the similarity will be there, then and it will check the RMSE and R2 score. So what is an RMSE? The RMSE measures the average difference between the predict state value and the actual state value. Here we have checked it using only using all three columns, that is news, that is newspaper, TV and radio, and in this we have taken only TV and radio, and Y is the same, so that we can compare both the models, and so we can see what are the RMSE and the R2 square scores, and so we can see over here that the RMSE is 1.40, and 0. And the R2 square is 0.916 approximately for the upper model, which has all three newspaper, TV and radio, and for only TV and radio the RMSE is 1.38, and the R2 square is 0.91. Since the second model has the lower RMSE and a slightly better higher R square score, it performs slightly better. Therefore, now it is confirmed that we are using the model with TV and radio because it provides better performance while using fewer input features. This confirms that the newspaper feature is not required for the accurate self prediction. So from here we are going to use this model only, which contains TV and radio. We will not take the newspaper model. So now model diagnostics, that's task 7. After evaluating the model using RMSE and R square, the next step is model diagnostics. Model diagnostics is the process of checking whether the trained model is making accurate prediction. Although evaluation matrix provides uh, a numerical result, graphical analysis helps us visual verifying the quality of the model. So what is model diagnostic? It is used to evaluate the performance of a trained machine, a learning model. It helps us compare the predicted value with the actual value and determine whether the model is making reliable prediction. So here we are taking an yellow brick library for visualization. We use yellow brick library. Yellow brick is a visualization library built on top of scikit-learn. It provides graphical tool that helps us better understand machine learning models. So in this we are plotting a graph, visualizing graph, which has an LM5 model and fits X train comma Y train, and the score and the graph we can see. So in the project, in the graph, each blue point represent one record from the testing dataset. The horizontal axis represents the actual sale value, while the vertical axis represents the predicted sale value. Then this identified line, the gray line. The gray diagonal line is called as an identity line. The line represents perfect prediction. If every prediction made by a model were perfect, all the blue points would lie exactly on this line. The base fit line, the black dash line represents the base fit line. It shows the overall trend of the model prediction. Ideally, this line should be very close to the identity line. The blue points, most of the blue points are very close to the identity line. This means that the predicted sales value are very close to the actual sales value. Therefore, the model is making accurate prediction. And the R square score is 0.918. This means that the model explains nearly 91.8% of the variation in sales, including very good predictive performance. Also, the model perform well. We can still try to improve it by creating a new feature. Then we use an interaction effect, which is called as feature engineering. This final improvement made in the project is introducing an interaction effect, also called an synergy effect. What is a feature engineering? It is a process of creating new feature from an existing data to improve the performance of machine learning models. Sometimes the original feature alone are not sufficient to capture all the patterns in the data. By creating meaningful and new features, the model can make more accurate prediction. So an interaction effect occur when two features work together to influence the output. Until now, the model considered TV, radio, advertisement separately. However, in real life, customer may first see an advertisement on TV and then later hear the same advertisement on the radio. The combined effect of these two advertisements may be greater than the individual effect. To compare these combined influence, we created a new interaction feature. So in this, the TV radio interaction we have created, which has separate TV and separate radio. Here the resulting value become a new feature called as TV radio interaction. This feature represents the combined effect of TV and the radio advertisement. So here we are training a new data. So we have to train another multiple linear regression model using the three input feature, that is TV radio and TV radio interaction with the cell. And then we are going to take all the similar thing splitting the data into train test, taking the random state and using an linear regression. If we have given the name of the class as interaction model, shipping the data into it, and then predicting the y, comparing it with x, and then printing it RMSP and RT and then we have created a uh, yellow brick graph which we have created over here. So in these both graphs, we can see that the gray line, the identity line, and the base fit line are very close to each other as compared to here, as compared to this graph. As you can see that the gray line and the black line are somewhat far from each other over here. They are perfectly on each other, and the blue dots are very close, are very close to it. So the visualizing prediction error graph for the improved model, we can observe the almost all the blue points lie very close to the identity line. This confirms that the improved model predicts the sales with very high accuracy. But why did the model improve? The model improves because it now understands not only the individual effect of TV and radio advertising, but it also combines influence. The additional information enables the model to make more accurate predictions. That's why now this is our final model, and we will take this model further. So through this project, I gained practical experience in complete machine learning workflow, including data analysis, data visualization, feature selection, model training, model evaluation, and feature engineering. Thank you for watching my project presentation.